Hi guys, so today we are on day 11 out of the book. So hopefully you have this watched before the next class period. And today, the only lesson we're looking at is lesson 51. So we have negative exponents and then scientific notation for small numbers. So we use scientific notation in the past for really big numbers, and we can do the same thing for really small numbers. Okay, so negative exponents, again, these exponential rules, they're all on your reference sheet. I think they use like A and then M and N or something like that, but it's the same concepts we're talking about here. So if we have the same base and we're dividing same base to a number, we do 5 minus 3. We subtract the exponents. Okay, so 5 over 3. We could write it out as we've done in the past, x times x times x times x over x times x times x. 3 of those are going to cancel out top and bottom. I'm left with 2 in the numerator, or x squared. But then if we have the same base and we're dividing, okay, and we're dividing 3x cubed by x to the power of 5, well, that's going to give x to the power of negative 2. And we can write it like that, or x to the negative 2 is the same as the reciprocal 1 over x squared. So the negative exponent doesn't make the outcome negative, it's just the reciprocal of that. So instead of x squared, it's 1 over x squared. So we can write it either way, x to the negative 2 or 1 over x squared. So if you do in your calculator, what's an easy one? We know 2 squared is 4, so 2 to the power of negative 2 equals 0.25, or that's 1/4. Okay, so 2 to the power of negative 2 doesn't make it negative 4 or anything like that. It's just the reciprocal. So 1 over 2 squared. 2 squared is 4, so 1 over 4 is 1/4, or 0.25. Okay, and this is the rule. Again, you can write it down. It's on your reference sheet. So anytime we have a negative exponent, we can rewrite as 1 over x to the positive exponent. So as we saw right here, the example we talked about, or this one right here. So in looking at this pattern of anything base 10, which is what we use for scientific notation, 10 squared, 2, we have 2 zeros, 10 to the power of 1, 1 0, 10 to the power of 0, we have 0, 0, so it's just 1, anything to the power of 0, except for 0 itself, but 1 to the power of 0, 10 to the power of 0, 20 to the power of 0, it ends up being 1. Okay, so same thing for base 10. 10 to the power of negative 1 is 0.1. 10 to the power of negative 2 is 0.01. So again, it's just we're moving the decimal. It's 10 to the power of negative 1. So now we went from 1 to 0.1 to 0.01. So every time this exponent goes up, we're going to be moving it to the left that many times, or I guess goes down. So negative 1, we move the decimal to the left one place. Negative 2, we move it 2 places to the left. Okay. Then I'll show you in class how we can work with our calculators to put in negative exponents. If you need help with that, we can go over it. So in looking at A, B, C, or D, which one of these does not equal 10 to the power of negative 3? Well, 10 to the power of negative 3, we could write it as a reciprocal of 1 over 10 to the power of 3. So A is correct. 10 to the power of 3 is 1,000, so 1 over 1,000, 1 1,000th. B looks correct. We have 1 1,000th in decimal form, 0.001. That looks correct. It is not negative 1,000, so D would be incorrect. Negative 10 to the power of 3 would be negative 1,000, but 10 to the power of negative 3, that negative exponent does not make the answer negative. If we had a negative base, then that could, depending on whether this was an odd or an even number right here, but we'll talk about that down the road. So it is not equivalent to negative 1,000. Okay, so think reciprocal. Think that we're moving the decimal to the left. The number is getting smaller. It's not just, well, 10 cubed is 1,000, so 10 to the power of negative 3 is negative 1,000. That is incorrect. Okay, so again, the same rules. If we have the same base and we're multiplying, okay, then we add the exponents. So negative 2 plus -4 equals -6 right here. Okay, if we're subtracting because we're dividing, same base, -2 minus -4, -2 minus -4 is the same as -2 plus 4, because minus a negative gives me positive, so that would be 2. Okay. If you put this in your calculator, it would come out to be 100, because it would be 10 squared, and that's 100. Okay, let's look at 2 to the power of -3. So if I have 2 to the power of -3, well, that equals 1 over 2 to the power of 3. 2 cubed, or 2 times 2 times 2, is 8. So this would equal 1 over 8. Or as a decimal, that would be 0.125. Okay, and then we also had, I think the other one was -2 cubed. So again, where the negative sign is and what the exponent is going to affect the answer. Now, when you're putting this into your calculator, that I like that they have the parentheses right here, because we need to include that. If you just do -2 to the power of 3, it's going to give you, well, I guess for this one it would be, it's going to give you a different answer than you are really supposed to get, because it's going to do the exponent and then make it negative, whatever it is. So it's going to change the sign on you. So just be aware of that. If you do -5 squared in your calculator, well, we know -5 times -5 is positive 25. But if you put it into your calculator without parentheses, it'll say -25. That's because it did the exponent and then accounted for the negative sign. So I'll explain more of that when we're in front of each other. But this one, we have -2 to the power of 3. So this is -2 times -2 times -2. Okay, so -2 times -2 is positive 4. 4 times -2 is -8. So negative numbers are kind of unique, because whatever this is, if it's an even number, -2 times -2 is positive 4. But then it was an odd number, -2 times -2 times -2 equals -8. So it kind of depends on what that exponent is. If it's even, we're going to have a positive number if we have a negative base. If it's an odd exponent and we have a negative base, then it's going to be a negative answer. So just can kind of be aware of that, of negative times negative is a positive. Positive times a negative is a negative. Okay. So what about if we have 3 halves? And this is actually good, because this shows, sorry, not 3 halves, 3 squared times 3 to the power of -2. We are going to end up with a fraction, but this is good because it shows us the rule of why everything to the power of 0 is 1. So if I have 3 squared times 3 to the power of -2, well, this can be rewritten as 1 over 3 squared. So write it all out again. Okay, so this is going to give me 3 squared times 1 over just 3 squared. Well, this is 9 over 9, which is 1. Okay, but also we say, well, 2 minus 2, we're dividing with the same base. So we could see that this is 3 to the power of 2 minus 2, which equals 3 to the power of 0, which equals 1, because we just showed it right there. Well, 3 squared over 3 squared, that equals 3 to the power of 0, but this also cancels out to just be 1 over 1, or 1. So that's why any number, it's the same thing, 5 squared over 5 squared. Well, 2 minus 2, that gives me 5 to the power of 0, 25 over 25, that equals 1. And so that's why any number to the power of 0 equals 1. That's what we're showing right there. Let's see. Okay, we'll see a lot of these types of problems in reviews and tests, just to count for, sometimes there may be x to the power of 1, x to the power of 2. So we may be multiplying things with the same base and we're adding those exponents. We may be dividing at the end as well and canceling out where we would subtract exponents. So just be aware of that. as we move forward. So scientific notation for small numbers, as we talked about. So let's look at this example here. So I have 1, 2, 3, 4, 5. So 5 zeros, so points. And so this is a really small number. This may be something we're looking at, under a microscope or something, or some really small particle that we want to express numerically. We can do it with scientific notation. So the same rule applies. I want my coefficient to be greater than 1 and less than 10. So it has to have a number in the ones place and everything else to the right of the decimal. Okay, and then we account for how many places I moved to get there. Well, to make this 7, I had to move 1, 2, 3, 4, 5, 6 places. So 10, but then obviously this number is larger than what I started with. So to get this back to this, I'd have to move it 6 places to the left. So this negative exponent doesn't mean this is a negative number. It just means it's a really small number, obviously less than 1. So these two numbers are equal. So if it's positive 6, we'd move it 6 to the right. Negative 6 means we move it 6 to the left. And we can write a 7 or 7.0 times 10 to the power of 6. Example 8, a lot of examples in this one. If I have 1 times 10 to the power of negative 6 and negative 10, well, this is going to give me a number less than 1, really small, 0.00001, 5 zeros, yeah. And then this is negative 10. So it's still greater than negative 10 because it's it's a positive number. It's a small number, but it's still greater than negative 10 because it's a positive number. So, all right, then the practice set we will go over together. That's all we got for today. So we will see you guys in class.